Hi, my name is Joshua Summermore, and this project is the environmental limiting factors of the Plankton paradox. So, starting off, what is the Plankton paradox? The Plankton paradox was a theory crafted by a scientist named G.E. Hutchinson in the 1960s. And basically, this paradox states is that you can have plankton, different species of plankton, coexisting within the same niche. And this was when he observed that plankton fulfilling their roles as primary producers. You had multiple species doing this exact same thing, or even plankton that absorb different nutrients like nitrogen. They will all have enough to go around, essentially. And this went against competitive exclusion. Competitive exclusion states that if there are multiple species within the same niche, then one will eventually outcompete the other. That's why you don't see many apex predators in a single ecosystem, right? Because the ecosystem can't support all those different species. But for plankton, there's an exception. Plankton are able to have multiple species doing the exact same thing, and the ecosystem is able to support all of them. Right. So I wanted to look at the environmental factors. I wanted to look at a certain aspect of this paradox, the environmental factors, and I chose three because of their importance to every single organism on the planet. The light exposure they have, the temperature that they sit at, and the nutrient concentration that they have available to them. And these uh, were crafting my question, which of these limiting factors has a significant impact on the species of plankton? Which ones had significant impact on these individual species of plankton? And how does that play in to the equilibrium that we see with them? So, first off, I decided to do two tests for accuracy. I wanted to do a fluorometer test and a hemocytometer test. Both of these tests are important, and they are very important in terms of looking at environments and how they actually operate in the world. So, the fluorometer test measured the fluorescence of the overall plankton concentration. So, uh, I had a batch of mixed plankton. This plankton was poured into six petri dishes, and each petri dish was assigned a variable. So one was a high temp, one was a low temp, one was temperature, a light, and a control. And each one was placed differently. So the high temp was placed at in an incubator of 21 Celsius versus the low temp, which was placed in an incubator of 19 Celsius. And the light concentration had the light source that was used for all of them facing away, and the nutrient concentration had less nutrients given to it throughout the intervals of the experiment, which was 7 days. So the fluorometer test shows the overall health of the plankton cultures and if these populations increase or decrease over the time of the experiment. And the hemocytometer test allows me to look at the and count the individual species of plankton to see which ones prefer certain environments more. That's done through taking a slide with a grid on it, and I'm able to use a method to individually count them. And what I found was, especially for starting off with the hemocytometer test, that once I took these data points and I ran it through a t-test comparing high temperature to low, nutrient to control, and the light to the control, I found that the species that were used, oscillatoria, which is one species, light and nutrients significantly affected those. Uh, Temperature was actually the most significant among three species, which was Eulothrix, Chlamydomonas, and Pandorina. The other two, Spirogyra and Scinedemus, those were not significantly affected by uh, any of the variables. So what that was important for was it gave me a new perspective on what matters to these cultures when it comes to these limiting factors, right? So you can see how certain species do prefer certain temperatures or certain conditions. So, and that also plays into the fluorescence. So, with the fluorescence, I ranked them. And what I found was is that high temperature and control, they showed a high amount of fluorescence that actually increased over the length of the experiment. So you're seeing how those populations grew. For uh, ones that did not grow as much or stayed constant was the light and the low temperature variables, and there was only one that actually decreased in overall population. That was the nutrient variable. So I decided, going back to the hemocytometer test, I decided to see if I could gain another perspective into these plankton. So I did a direct comparison. I just took these numbers, these means, these averages, and I put them together on the graph basically. And I just looked at them. I wanted to see, okay, which one prefers this, which one prefers that. And I saw that these plankton, especially with the temperature, they have a wide variety of things that they like. Again, some of them prefer a higher temperature, some prefer a lower temperature, some they're indifferent to either, right? And ultimately, this experiment is important for ecosystems around the world because plankton are very important, as I stated earlier. They are the building blocks of these environments. So, having these plankton species working in coexistence, that is very important for having a successful ecosystem. And looking at how the plankton paradox plays into that and how it creates an equilibrium that allows for this successfulness, hopefully one day a model can be made where people can go, okay, this is what works for the plankton paradox. Let's see if we can apply this to other environments. So, environments that have endangered species, for example, right? And seeing how uh, the effects of the plankton paradox, whether it be through niches, whether it be through evolutionary traits, right? And just having this comprehensive idea of what the plankton paradox is, and this experiment helps to contribute to that comprehensive view. So hopefully, more experiments can be done on the plankton paradox. Hopefully, more awareness can be brought to it, and just for more people to see how important it is to maintain these ecosystems starting from the very bottom, which is plankton. So, thank you for listening, and have a great day.